All right, I think it's 1 o'clock. It's Tuesday, it's 1 o'clock. That means it's time for another HDF clinic. Welcome, everybody. I just checked our cheat sheet here. Nobody has submitted any questions, which is okay. But if there are any, I'm going to pause here. And for those of you who were joining, are there any questions before we sort of go through our usual motions? No? Okay, then we'll jump right in. I'm happy to report I kept, for the last maybe 5 or 6 meetings, I kept dragging this question around, and this morning I just sat down and just write a test program and check it out. And so I'm happy to report that question that we were sort of kicking around was the question, okay, you would like to do an H5D read or H5D write, and then the question was, well, let's assume the selection that you have in memory and the selection that you have in the file are of 2 distinct types, one of the 2 being a point selection and the other being a hyperslab selection. And would that work for reading and writing data? And a while ago, I presented a simple sequential program where we sort of verified, yes, that is not a problem at all, and it just works. And then we sort of asked ourselves, well, would the same work also in parallel, meaning MPI parallel in this case? And my intuition, so to speak, or my gut feeling was, yes, that should work just the same way, but I didn't really offer any proof. And so what I did this morning is just quickly sit down and write an example program, and here it is. There's just the usual boilerplate here, so nothing to write home about. We have to initialize MPI, get our bearings on how many ranks there are and what the size of the communicator is, create a file access property list to tell the HDF5 library that we want to use MPI-IO, and then just go ahead and create a file, an HDF5 file with that file access property list. Great. Okay, so then we will just go ahead, and in this case, what we'll do is we will create a one-dimensional data set, and since we are running in parallel with size, that's the size of the communicator, so in this case it's MPI convert, so that's the number also of ranks, of MPI ranks, and so I create a one-dimensional data set that has twice the number of ranks elements. So for each rank, we will have sort of 2 elements. And we just created a data set, an integer data set in this case, with this file space. And then on each rank, we basically create a 2-element memory space. H5S create simple and make it 2 elements. And then we just create an data array or data buffer in each rank, and the 2 elements in that buffer or array are 2 times rank and then 2 times rank plus 1. So that means on rank 0, this is going to be 0, 1. On rank 1, it's going to be 1, 2, and so forth. So fair enough. And then we make 2 selections. We do a point selection in memory where we basically select this first element. So this is always twice the rank. So it's going to be 0, 2, 4, and so forth. And then we make a hyperslab selection in the file. And of course, since we are selecting only a single element in each rank, in each MPI rank, we can select only effectively a single element. So this is a very contrived hyperslab, but it is a hyperslab nevertheless, where we basically choose 2 times rank as our offset. in the data space in the file, and then we are doing one block, and the block size is also 1 in this case, and that's it. And then we are calling H5D write. So we would expect, if this works, that once this write operation completes, that since we are ignoring the second element here in our data buffer, that's just there for to kind of align with our definition that we have a data space of size 2 in each rank in memory. But we would expect in the file, when this data set is written, a one-dimensional data set that has 2 times the number of MPI ranks elements, and the elements that are being written is every other element. So we would expect to see 0, 2, 0, 0, 2, 0, 4, 0, and so forth. So only the even places get written. And then again, just shutting down here, freeing the resources, and shutting down MPI and so forth. And that's it. So very, very simple program, really more boilerplate than everything else. And so if you compile this program, run this program, I can show you a simple sample run here where I just ran this with MPI exec-n, so with 4 ranks, and then I called the executable selection underscore par, and that generates the file that we created here, selection underscore par.h5. And if I run h5 dump on that, lo and behold, okay, we have 4 MPI ranks, or our communicator size is 4. That means we are creating a data set with 8 elements total, and then we are just writing the even ones. So we expect to see 0, we expect to see 2, we expect to see 4, and we expect to see 6, and that's what we are getting. So that, in a way, puts that concern of ours that, well, does that really work in parallel to rest? And so, yes, we can say, if you're working in parallel, in MPI parallel, and you have in memory a point selection, and in the file a hyperslab selection, or the other way around, that just works, no problem there. I would even go, I'm not going to create another such problem and then carry it around for 5 weeks or something like that. The next level of generalization would be, well, wait a minute, could I have a, since on these individual MPI ranks, I can now play with these in-memory selections, and I could have, let's say, on the even ranks, I could have a point selection, and on the odd ranks, I could have a hyperslab selection or something in memory, writing all to the same hyperslab selection in the file, or a point selection in the file. Would that work? The answer to that question is also yes. If you don't believe it, I invite you to try this out, but it's basically a variation of this theme. So that's still the only restriction as far as selection really goes that remains in HDF5 is really that when it comes to these operations, these set theoretic operations that you can do on selections, you have to remain within the same class of selection. So you can form the union of point selections, you can form the union or intersection or difference of hyperslab selections and so forth, but you cannot mix and match point selections and hyperslab selections as far as these set theoretic operations go. But other than that, it looks like everything else is good. And so yeah, I was just doing my homework and finally get this out of the way. Okay, I'm going to pause here and ask if there are any questions about that, or any other questions at this point.
No questions from me, group.
Okay, thanks. Okay, last week's highlights. Announcements. Two announcements. The Vault tutorial was postponed. It's coming up. It's going to happen February 25th, 11 to 1 p.m. Central. I really look forward to that. And then there was this, I mentioned it last time, but didn't put in the link because the link was posted just after I had put together these notes. But here it is again, nice blog post about the use of HSDS in biological simulations. And go check it out, and it's really an interesting read. Okay, forum. Last time there wasn't really that much happening in the forum. In the meantime, a lot has happened on the forum, and last time we did a little bit more extended show and tell and tips and tricks, but today we'll do a little more forum and skip the tips and tricks, unless there are other questions. Okay, there was a forum post about recovering a corrupted data set. It turns out, if you go back, that the user reported back, and he did an analysis, and oops, sorry, I just unmuted myself. I think it should be.
Oh, it was better before. Sorry.
Are we okay?
Yes.
Oh. Okay, is that?
That was a little more distant. I'm sorry. I was trying to make something better. Trying to fix the video.
Can you hear me?
Yes.
Can hear you now.
Okay.
Yes.
Okay, good. Thanks. Sorry. Yeah. Okay. So right, recovering corrupted data set. So it turns out the user actually did quite a bit of work and analysis. It turns out that because when he posted it initially, we were concerned maybe there was corruption across the file somehow, but it turned out to really be localized to a particular data set, because he was able to run H5 dump and just to see what's in the file, the groups in the data sets and whatnot. And it turns out that he was able to basically, with our sort of chunk function, where you can read individual chunks, you can write individual chunks, and you can also determine, retrieve information about these chunks and so forth. He was able to retrieve individual chunks, and of the however many chunks there were in this particular data set, there was a single chunk that was corrupted. And of course, the behavior that he saw was, when he did sort of an H5D read, that behind the scenes, in a way, iterates over all the chunks, and if it encounters a single chunk that is somehow corrupted, then the whole operation would fail, or it would basically return a negative return value, indicating that there was trouble. But he was able to actually read the data set chunk by chunk, and chunk by chunk, in the sense that if there is data in the file, the HDF5 library will just read it. It will not try to interpret the data. So in this case, I already forgot if the user actually used any kind of compression on that. I believe compression was involved. But if you're reading the raw chunk, the HDF5 library is not going to send that chunk through the traditional filter pipeline. So even if there were a problem uncompressing the chunk, the error would not come from the HDF5 library, but when you then sort of take that raw chunk and then try to deflate it, or whatever compression algorithm is involved. So this user was really able to establish that it was just a single chunk. And then, of course, I don't know how much detective work you then want to spend on finding out how that individual chunk got corrupted, and so that still remains a bit of a mystery. But the user was able to recover the good chunks via just H5D read chunk, and so I think that was interesting to see and good to see. Sure, if that chunk was the most important chunk in the whole data set, I'm sorry, but yeah, it was still, I think it required some skill, but obviously he managed to do that, and so that was, I think that was a fun read. Not so much fun for the user if they lost some data, but still good to see that users can use these APIs and make the best of the situation, so to speak. Next up was also related to compression, and so the way it's framed here is the user said that, okay, I have that file and I'm trying to open it in HDF view, and but I'm not seeing what I'm expecting. In fact, it appears that HDF view somehow has trouble uncompressing it or showing me anything meaningful, and it's in a way related to the previous post that these chunk level operations, and I kind of remember discussions in the HDF group that we had when we sort of were considering introducing these chunk level operations, letting users reach into the file directly, be it to read or write these chunks, that we would these are not exactly dangerous is the wrong word, but these are operations where you have to really understand what you are doing there. And if you do that, you can use them to great efficiency and do very interesting things. But if you do not understand what these operations do and don't do, you are potentially in for quite a bit of trouble. And I think that's what happens here. What happened here, and the user, I think, also responded to that effect. He thought, or he maybe misunderstood what, in this case, H5D write chunk did and didn't do. I think he wanted to do compression outside of HDF5, which is perfectly fine outside of the HDF5 library, and then use H5D write chunk. I believe, though, what he didn't realize is that when he created the data set, he did not create it. He created it with chunking enabled, but he didn't tell the library that he actually would be using gzip or deflate compression, which means that that metadata would be lacking. So later, when you, for example, point HDF view or any other tool at this data set to read it, and you wrote compressed chunks in there, since the chunk will be read and in reverse in the read sort of go through the filter pipeline, but there is no filter registered because there's nothing in the metadata to tell HDF view or the client application. It just treats this chunk as whatever the type is, let's say integers, as a chunk of integer data, and will try to read that data, and then it will just read, if assuming that was gzipped or treated somehow, it would read garbage, and you wouldn't see what you expect to see. The interesting thing in this case actually would also be, if compression was effective, then typically the compressed chunk would be smaller than the uncompressed chunk. So so now that I think about it, I'm actually surprised that the library wouldn't have created an error there saying that, hey, I'm looking at a chunk of a certain size and it's, let's say, integer for argument's sake. So the library knows exactly how many bytes to read. And okay, if the file is big enough, it will just read those bytes. But then I'm actually not sure if the library will look at sort of the file extent allocated for this chunk and realize, well, that physical chunk is actually smaller than what it should be, and perhaps raise an error. It might be interesting to sort of circle back to the user and ask if they saw any kind of error messages. So that's something I don't know off the top of my head. But long story short, it's okay to use these chunk operations and everything, and do whatever transformation you want to do outside of the library, where you're not subject to certain constraints regarding multi-threading and so forth. But you have to be sure that these data sets are properly constructed, meaning they have the right metadata, the right information about the filter pipeline and which filters are there. Okay, that was a good one. Maybe I can pause for a moment and ask, are there any questions so far?
Gerd, I had one question on his solution.
Okay.
He wrote that eventually, when he went back and fixed this, he used hyperslabs. Rather, so he was trying to do something by writing his chunks individually that really should have been easily or much better done using select hyperslabs. Was that kind of where the mistake originally got made there?
Perhaps. I think he also commented, he said that he used H5D write rather than H5D write chunk. So I think there are maybe two sources of errors here. Number one is that if you do an H5D write, then you go through the filter pipeline, which includes any kind of selections that you do on that chunk or transformations and so forth. Whereas, when you do a hyperslab selection and then you directly read or write a chunk, that is completely ignored because you are saying to the library, here's a chunk, and put that directly into the file where it belongs. If you have a selection, there is actually, when you do an H5D write chunk, there is actually no select, unless you are writing multiple chunks, there is no selection involved whatsoever. So maybe he hadn't internalized that, and he thought, well, maybe the selection would be somehow effective, maybe, but no, it's just the library takes that chunk and puts it straight into the file, ignoring any selections that there might be.
Okay.
Then there was another question, and that was more of, it's one of these things where we frequently ask ourselves, well, should this be included in release binaries or in releases? And someone pointed out that we provide this archive of pre-built binary plugins for the library. And then as part of that distribution, there are example HDF5 files in which some of these, for testing, in some of which these filters, these plugins have been applied, and there's a sort of a sample data set in there so that people have an opportunity to actually verify that the plugin is working and it's working correctly. But then the user noted that there are these .err files, so to speak, and he was concerned that maybe, okay, they were downloading a binary package, so they were not really building it from source, but perhaps they were confused that maybe as part of the installation, maybe some kind of testing would take place, and the presence of these ERR files suggested that maybe something went wrong with the installation. And I would give them that is certainly confusing, but they are really there. If you look carefully at them, they show in a way a templated error message that programs or users would encounter if a plugin of that specific type were missing. And it's sort of generic in the sense that there is, I think, as I pointed out, there is in parentheses a file name, and in parentheses a line number. And of course, in a real build, these would be populated with the file name in which that error occurred and the line number in which that occurred. But of course, as we make changes and check things into the HDF5 library, the line numbers and in some cases the file names would change. So hard coding that wouldn't really help. And so long story short, these files are really there for diagnostic purposes. Now, could they be stripped from release binaries to eliminate that confusion potential, let's call it that? Perhaps, but yeah, I can ask, have a conversation with our engineers to see what they think, or if they have reasons where they might say, well, this might be useful for people out there. And in the end, it's probably then you can't do it right for everybody. And then, yeah, when in doubt, we have to somehow find a compromise and say, well, maybe for the few developers or testers out there, it's good to have. And then could it be confusing to some people? Yeah, also, but yeah, it's not always easy. Okay, next one was a good one, and I forgot if we've spoken about that in the past. The user was asking that, okay, they have an external link. An external link is just one of these nice things. Logically, you can think about it as I have opened an HDF5 file with a certain access mode, let's say read-write, and then I'm encountering an external link, which is typically a reference to an HDF object in another file. So logically, you can think of it as a file name, comma, as a tuple of a file name and an HDF5 path name, instructing the library basically to say, well, in order to dereference or understand what this, what the referent of this link is, go open that file and then traverse that path, and the object that you find there, that's the one that I'm talking about here. Now, the interesting question is, of course, since a file, when you do an H5F open, let's say, the question is, well, in which mode do you open the file? Do you open it read-write? Do you open it read-only, and so forth? And then the question is, when you have such an external link, what is the default, if you want to call it that, access mode for that external link? And I think the default access mode is what you would probably expect, which is that since that external link itself is placed somewhere in a group, somewhere in a file, the default access mode for the file that is being referenced or part of this external link would be the access mode of the, call it the parent file of that link. But of course, there are circumstances, and in this particular posting, the user was saying, well, I would like this to be, let's say, the parent, the access mode of the parent file is read-write. However, I would like to access a file that is actually, let's say, by the operating system, by the file system, marked as read-only. So I can't really open that read-write because that would return an error. So then the question is, well, can I override this behavior, this default access mode behavior? And the answer is yes. As in so many cases, there is a property or property list for that, and it can be overwritten via, in this case, it is something that is not stored inside of the link, because that information about the destination file is not really part of the link's metadata or information about the link. It's really something that you impose at runtime on this link. And so there is this function called H5P set elink ACC access flags, where you basically provide the link access property list itself, and then the access mode, the same access mode that when you do an H5F open, to instruct the library and say, hey, when you traverse that external link, use this access mode for these files. And that, I think, has the desired effect in this case. The next one, and this is just something I think that came in today or last night, an interesting question about a compression filter that employs multiple data sets. And so the motivation was here, typically, we compress or filter data sets of numbers or certain types. In this particular case, what the user had in mind was, let's say you store mesh connectivity. So mesh connectivity really means you have vertices and edges or elements or something like that, something the connectivity, and obviously the more regular that connectivity is, let's say the triangles or the quadrilaterals or the bricks or whatever the element type might be, you might be able to actually compress that connectivity pretty well. But as we can see, that involve multiple data sets. And if you look at the current filter extension API, if you want to write a custom filter for that, that API actually has no support to make references to other data sets, because obviously one of the data sets that you would, in addition to the data set storing the connectivity itself, or there might be other data sets if you have different element types, but then obviously you would be making reference to the data set of vertices, for example, of grid points. And then there is no obvious way in the filter API to do that. And so this is a discussion that has just begun. If you are interested in that, catch up on it, and yeah, we will see where this goes. I personally think that maybe with the computational data set that computational data sets that Lucas developed, something can be done here. But then, yeah, it really depends on, I believe, Mark, who created this post. Maybe he can elaborate a little more on how his compression method actually works. And then, yeah, maybe we can come up with some other solutions. But this is definitely an interesting topic to follow. And I'm afraid we are out of time. So thank you for coming. And I hope you will come back next week, where we will have more interesting topics to cover. Thank you.
Okay, thanks, Gerd.
Thank you. Bye.